Swayam Prabha. Digital India. Educated India.
Reduction in pollution load in textile effluent. Lecture number 23. What are the now? Let us slowly understand what are the methods of pollution reduction in the wastewater, so that the treatment for the load becomes easier. Now, looking at this chart, minimizing the impact on environment is of course the main criteria, and all the chemicals, raw material, water, they all go into the textile industry as an input, and because of different types of processing that happen in the textile industry, a lot of effluent, sludge, air pollution and finished product is produced, and this effluent can then have an adverse effect on the soil. It can affect the soil fertility, the microorganisms that are present in the soil, acidification of the land, porosity of land reduces and underground water levels become contaminated crop. So, these are the adverse effect on the soil itself. Now, adverse effect on the water bodies also we have learnt. Toxic to fish and aquatic life, reduces dissolved oxygen, thereby killing the fishes. Endocrine disruption of fish reduces fish reproductive system and reduces algal growth and develop dead zone in the sea and water bodies. So, there is a need for wastewater treatment, and by now we have understood this very clearly, that textile wastewater cannot be let out without treatment into the water bodies. Effluent from dye house, what does it contain? From desizing, we know sizes like starch, enzyme, waxes, carboxymethyl cellulose, PVA, polyvinyl alcohol will be just from the desizing and sizing step. Scouring step will have sodium hydroxide, surfactants, soap, fat, waxes, water softeners, and will have very high pH, alkaline pH. Bleaching step will have hydrogen peroxide, organic stabilizer, chelating agents, sodium hydroxide, and again will have very high pH. Dyeing step will have color, metal, salts, surfactants, sulfide, could be acidic or alkaline, formaldehyde, water softeners, urea and silicones. If it is going through printing, then urea, solvent, color, heavy metal, thickeners, binders, etc. will be present. And when finally it is going for finishing, it will have resin, waxes, silicone softener, PE softeners, etc. So, you see that there are a variety of compounds, and we have seen this time and again in many of the lectures. It could be seeming to be repetitive, but it is for the emphasis that these are the culprits for pollution load. So, how do we reduce the pollution load in textile effluent? Now, that is the main issue. Reducing the pollution load in textile effluent involves a multifaceted approach that combines technological advancements, regulatory measures and industry-wide initiatives. Here are several strategies commonly employed. Advanced treatment technologies, and we are aware of that, we have learnt about them. Implementing advanced treatment technologies such as biological treatment like activated sludge process, aerobic granular sludge process, chemical treatment like coagulation, flocculation, and physical treatment like membrane filtration, adsorption can significantly reduce pollutants in textile effluent. And by now, I think you may have even gotten by heart by this all these details that we have already talked about. Water reuse and recycle. And I had also told in one of the previous lectures that water is becoming a scarce commodity, and therefore, there should be an aim along with pollution load reduction, how to recycle and recover water so that it can be used in the same textile unit again. Implementing water reuse and recycling systems within the textile manufacturing facilities can reduce the overall water consumption and minimize the discharge polluted effluents into the water bodies. Process optimization, we have even discussed this point in quite detail, that process optimization, chemical management have become now the need of hour, because only by these two methods we can reduce the load. Some chemicals have to be used, there is no way out that we can omit them, but if they have to be used, they should be used optimally. Optimizing textile manufacturing processes to minimize water and chemical usage as well as maximizing resource efficiency can decrease the pollution load in effluents. Zero discharge liquid discharge, that is ZLD. Implementing ZLD systems can help in minimizing liquid waste discharge by recovering water from effluent and recycling it back into manufacturing process. And this is exactly what I was mentioning a while ago, that somehow there should be minimum water usage and that water also should be recovered so that there is zero liquid discharge from the textile unit. Effluent treatment plant upgradation. Upgrading existing ETPs with more efficient and modern treatment technologies can enhance the removal of pollutants from the textile effluents. Now, here I would like to emphasize that mills which are running for more than now 20-25 years have had the ETPs which were designed for conventional traditional treatment methods, and many now new modern methods have come up. So, there should be some changes in the infrastructure so that they can accommodate and practice modern technologies. Compliance with the environmental regulation. Ensuring compliance with stringent environmental regulations and standards is crucial for controlling and reducing the pollution load in textile effluent, because if compliance for the stringent values of the discharged effluent is not taken into account, what will happen that we will continue to pollute the water bodies in and around the mill, and therefore, regulations will go haywire. So, there should be strict adherence to what the environmental regulations have been laid down for. Green chemistry practices. Adoption of sustainable and green chemistry practices involve substituting hazardous chemicals with safer alternatives, thereby reducing the overall environmental impact of textile manufacturing processes. So, wherever possible, if the chemical can be replaced by biodegradable chemical, then we will say it is approaching the green chemistry approach, and that it is working towards sustainability. Employees training and awareness. Educating employees about the importance of pollution control measures and providing training on efficient water and chemical management practices can contribute to reducing pollution in textile effluent. So, this is also one of the ways of reducing the pollution load. If the workers in the mill are trained and are made aware that chemical management system should be implemented, optimization use of the chemicals should be practiced. If optimal compounds are used, then the chances of those chemicals load in the effluent will be much lower. Collaborative efforts. Collaboration among textile manufacturers, government agencies, environmental organization and research institutes can foster innovation and drive collective efforts towards reducing pollution in textile effluents. By integrating these strategies into textile manufacturing processes, it is possible to significantly reduce the pollution load in textile effluents, leading to a more sustainable and environmentally friendly industry. So, it is not the job of just one person that the mill owner has to only worry about it. Government agencies, environmental organizations and research institutes should come up with new technologies, and all put together it should work for the basic cause of reduction of pollution load in textile effluents. Benefits of reduction in pollution load in textile effluent. Reducing the pollution load in textile effluent yields numerous benefits, both environmental and socio-economic, which contribute to a more sustainable and healthier ecosystem. Here are some key benefits. Improved water quality. When there is a reduction in pollution load, it will lead to improved water quality in surrounding water bodies such as rivers, lakes and groundwater. They will be less contaminated or not contaminated at all. This benefits aquatic ecosystem, wildlife, communities reliant on their water sources for drinking and recreational activities. Protection of biodiversity. Lower pollution levels help to protect aquatic biodiversity by preserving habitats and supporting the survival of various aquatic species. Healthy ecosystem also contribute to ecosystem services such as pollination, soil fertility and carbon sequestration. So, see what I was telling in one of the lectures earlier, that if the water bodies get contaminated, it affects the aquatic ecosystem, and if it affects the ecosystem, they will start dying, and slowly we will lose those biodiversity in long term of time. Hence, we need to, because in the food chain, in our chain of evolution, each one, vertebrate, invertebrate, all play a very vital role. Each one of us are connected, and that is how the pyramid grows. So, if one chain is lost, then there is a big loss. Healthier communities. Decreased pollution in a textile effluent reduces the risk of exposure to harmful chemicals for communities living near manufacturing facilities. This can lead to lower rates of waterborne diseases, respiratory illnesses and other health issues associated with contaminated water and air. Sustainable resource management, efficient water and chemical management practices associated with pollution reduction promote the sustainable use of resources. By conserving water and minimizing the use of hazardous chemicals, textile manufacturers can reduce their environmental footprint and preserve natural resources for future generation. Now, if the communities are healthy and there is decreased pollution due to textile effluent, definitely it will reduce the risk of exposure to harmful chemicals for the communities. Undoubtedly, this can lead to lower rates of waterborne diseases, respiratory illnesses and so on. Similarly, if we have a sustainable resource management, that is efficient water and chemical management practices associated with pollution reduction to promote the sustainable use of the resources. We should not use anything in excess. All optimized quantities can automatically bring down the pollution load. Compliance with regulation, meeting or exceeding environmental regulations regarding pollution control enhances the reputation of textile companies and foster trust among consumers, investors and regulatory authorities. Compliance also reduces the risk of fines, penalties and legal liabilities associated with environmental violations. So, if the load is low, the danger of exceeding the stringent levels also will be low, because the treatment methods will be followed, and so there would be no fine or legal aspect penalties associated with environmental violations. Cost saving. Implementing pollution reduction measures can result in long term cost saving for textile manufacturers. By optimizing processes, reducing resource consumption and minimizing waste generation, companies can lower operating cost and improve overall efficiency. So, because the reduction of pollution load is also cost effective, if the load is less, it will be cost will be cut down and there will be cost saving. So, reducing resource consumption and minimizing waste generation, companies can definitely lower operating cost and improve overall efficiency. Market competitiveness. Consumers are increasingly demanding products that are environmentally sustainable and ethically produced. Textile companies that demonstrate a commitment to pollution reduction and environmental stewardship gain a competitive edge in the market and attract environmentally conscious consumer. And this also we have discussed, that if a company is doing everything in a sustainable manner, obviously that company has an edge over other companies who are not doing in the sustainable manner. Therefore, that company gets more attracted by the products of that company get attracted and the consumers get attracted to those type of companies. Innovation and collaboration. The pursuit of pollution reduction foster innovation within the textile industry. leading to development of cleaner production technologies, sustainable materials and eco-friendly practices. Collaboration among industry stakeholders, researchers and policy makers further accelerate progress towards sustainable solution. So, continuously new methods, new technologies, better technologies, best technologies need to be brought into the mills, and this can only happen if there is collaboration between the research organization and the mills. Therefore, collaboration among industry stakeholders and researchers and those who are policy makers become very important. Overall, reducing the pollution load in textile effluent not only benefits the environment and public health, but also strengthens the resilience and viability of the textile industry in the long term. Because we know that as long as human beings exist on the planet, the textile industry will thrive. How to minimize pollution load? That is the main problem in today's time. The production processes of textile manufacturing not only consume large amounts of energy and water, but also produce a significant amount of waste product. It is this waste that needs to be minimized to reduce the pollution load in textile effluent. Practices like sustainable dyeing, the use of new and less polluting technologies, effective treatment of effluent and recycling waste processes need to be adapted. So, the bottom line is that how do we do it? So, by practicing sustainable dyeing, the use of new and less polluting technologies, using biodegradable chemicals and by effective treatment of effluent, whatever load is there that should be effectively treated, so that the water that can be produced or discharged water can be recycled, and this, if these principles are adapted, then that is the most ideal situation. Sustainable dyeing to reduce the pollution load in textile effluent. So, let us move on to how do we reduce the pollution load at the very onset. Sustainable dyeing methods can be significantly used to reduce the pollution load in textile effluent. Here are some approaches. Natural dyes. Utilizing natural dyes extracted from plants, insects or minerals can be an eco-friendly alternative to synthetic dyes. These dyes are biodegradable and often require less water and energy during the dyeing process. Now, extensive work is now being done in the area of natural dyes, because more and more number of dyes are being isolated from different plants, different parts of plants, animals and other minerals, and these are all biodegradable because they are from the natural source. Low impact synthetic dyes. If we have to use synthetic dyes, then using low impact synthetic dyes will be another alternative. Some synthetic dyes are designed to have lower environmental impact compared to traditional ones. These dyes are formulated to be more efficient, requiring less water and energy, and they generate fewer harmful byproducts. Dyeing techniques. Innovative dyeing techniques such as cold dyeing, foam dyeing and supercritical fluid dyeing can reduce water and energy consumption while minimizing pollution. These methods often require lower chemical and produce less wastewater. So, at every stage natural dye should be used in place of synthetic dyes. If synthetic dyes have to be used, then those low environmental impacting dyes should be used, so that they biodegrade or they degrade easily. Techniques of dyeing should be adapted which require less water and which have less cold dyeing and foam dyeing. They use very little of water. So, energy is saved in cold dyeing, foam dyeing requires very little water, and supercritical fluid dyeing does not use any water, but they use carbon dioxide liquefied as the solvent. Water recycling and treatment. Implementing water recycling system and efficient wastewater treatment processes can help reduce the amount of contaminated water discharge into the environment. Advanced treatment technologies such as membrane filtration, electrocoagulation can effectively remove dye molecules and other pollutants from the textile effluent. Bio-based treatment. Using biological processes such as microbial degradation or enzymatic treatment can break down dye molecules in textile effluent, making them less harmful to the environment. Bioremediation techniques can be employed in wastewater treatment plants to detoxify textile effluent before it is released into the water bodies. So, both water recycling through membrane filtration and electrocoagulation is now vouched for, whereas bio-based treatment plants where microbial degradation and the enzymatic treatments are highlighted must be used, so that it can detoxify textile effluent efficiently. Sustainable chemicals, that means choosing eco-friendly chemicals and auxiliaries in the dyeing process can minimize the environmental impact of the textile production. This includes selecting non-toxic, biodegradable and renewable raw materials for dyeing and finishing. Dyeing automation and optimization. All along we have been talking about optimization. Adopting automation and process optimization technologies can improve the efficiency of dyeing processes, reducing resource consumption and minimizing the generation of waste and pollution. By integrating these sustainable practices into textile dyeing processes, manufacturers can significantly reduce the pollution load in textile effluent while promoting environmental stewardship and sustainability in the industry. So, all along we have been talking that if we optimize is the word which can directly reduce the pollution load. If we understand that, then the strategies have to be designed, the dyeing processes have to be designed accordingly. Reducing the pollution load in textile effluent requires the adoption of less polluting technologies across various stages of textile production. And here are some key strategies. How do we use less polluting technologies to reduce the pollution load? Because in this lecture we are emphasizing mainly how to reduce the pollution load in textile effluent. What are the means and methods of doing that? Waterless or low water dyeing technologies such as air dyeing, where color is applied using compressed air instead of water, or dyeing processes that use minimal water like dye sublimation can significantly reduce water consumption and minimize the volume of wastewater that is generated. So, somehow if we can adapt waterless or low water dyeing procedure, that would be the most ideal situation. Digital printing. Digital printing techniques such as inkjet or digital textile printing allow for precise color application with minimal waste. These methods eliminate the need for water intensive dye baths and reduce the use of chemicals, resulting in lower pollution levels in textile effluent, because digital printing requires very little water and therefore, too much of water is not required and there is water saving by itself. So, obviously, there will be less of textile effluent generated. Sustainable fiber production. Using fibers derived from sustainable sources such as organic cotton, bamboo or recycled polyester reduces the environmental impact of textile production. These fibers often require fewer chemicals and water during processing, leading to cleaner effluent. So, if we look at some of these latest kind of fibers that have been brought into the market, such as organic cotton, bamboo and recycled polyester, then also it reduces the environmental impact of the textile production. Closed loop system. This is one new thing that we will be learning. We have mentioned this in the earlier lectures, but very briefly. Implementing closed loop system where chemicals, water and energy are all recycled within the production process helps minimize resource consumption and waste generation. By continuously circulating and treating process water, closed loop system reduce the discharge of pollutants, and this is one of the best ways. If we can do this, whether or not we can do it in all cases is another question, but if we can do it, it would be the most ideal situation to do. Ozone treatment. Ozone technology can be used for bleaching and color removal in textile processing, reducing the reliance on chlorine based bleaches and chemical oxidants. Can we use better oxidants? Can we use oxidants which are milder as compared to chlorine based bleaches? Ozone is a powerful oxidizing agent that can effectively degrade organic pollutants without producing harmful byproducts, because ozone is O3. When it dissociates, it forms oxygen and nascent oxygen. So, this nascent oxygen is the one which does the oxidizing or the bleaching action. Biological treatment. Employing biological treatment system such as constructed wetlands or activated sludge processes can biodegrade organic contaminants present in the textile effluent. Microorganisms naturally break down pollutants, resulting in clean water discharge from the treatment plant, and this we have done in great detail. So, we know that biological systems are one very eco-friendly technology which can reduce the pollution load definitely. Nanofiltration and reverse osmosis. Advanced membrane filtration technologies and nanofiltration such as nanofiltration and reverse osmosis can effectively remove dyes, salts and other pollutants from the textile effluent, producing high quality treated water suitable for reuse and safe discharge. So, they generate water which can be well suited for recycling and reuse, or they can be safely discharged. Solar and renewable energy. Utilizing solar and other renewable energy sources to power textile production processes reduces reliance on fossil fuel and lowers greenhouse gas emissions. This shift to cleaner energy sources contributes to overall pollution reduction in the textile industry. So, it is not always the water that is bad, even the air emission where greenhouse gas emission can be reduced, even that is lowering the pollution load. By incorporating these less polluting technologies into textile manufacturing processes, companies can minimize their environmental footprint and work towards sustainable and responsible production practices. So, what are the effective treatment of effluent for reducing the pollution load? Let us try to consolidate that information. Effective treatment of effluent is crucial for reducing the pollution load and mitigating the environmental impact of the industrial activities. Here are several methods for treating effluent effectively. Physical treatment, sedimentation, filtration, membrane filtration, etc. Sedimentation allows suspended solids to settle out of the effluent through gravity and can remove a significant portion of pollutants. Filtration, passing the effluent through various filtration media such as sand filters or multimedia filters can remove suspended solids and organic matters. Membrane filtration, using membranes with fine pores to physically separate contaminants from the effluent. This includes microfiltration, ultrafiltration, nanofiltration and reverse osmosis, which can remove particles, microorganisms and dissolved pollutants. And this we have studied that physical separation, physical treatment is equally important. Then comes chemical treatment. This also we have covered, but we are consolidating now all the information as to how to reduce the pollution load. From that perspective, we are learning this lecture. Chemical treatment, coagulation and flocculation, adding chemicals such as alum or ferric chloride to destabilize suspended particles and to facilitate their agglomeration into larger flocks, which can then be easily removed. Oxidation, using chemical oxidants like chlorine, ozone, hydrogen peroxide or potassium permanganate to break down the organic pollutants into simpler and less harmful compounds. pH adjustment, controlling the pH of the effluent through the addition of acids or bases can optimize subsequent treatment processes and enhance the removal of certain contaminants such as heavy metals. Now, let me tell you here that if pH adjustment is not done before biological treatment, there is a possibility that the microbes that are kept in the biological treatment reactors can die at very high or low pH. So, therefore, pH adjustment is also very much required in order to reduce the pollution load. Biological treatment, activated sludge process, aeration tanks with microorganism breakdowning the organic matter in the presence of oxygen, forming activated sludge that can be settled out or recycled. Trickling filters, effluent is trickled over a bed of media, providing a surface for biofilm formation where aerobic bacteria degrade organic pollutants. Constructed wetlands, natural or engineered wetlands planted with aquatic vegetation that facilitate biological degradation and filtration of contaminants through microbial activity and plant uptake. Then we have the advanced oxidation processes. Photocatalysis, we have just studied a while ago. Using catalysts such as titanium dioxide activated by ultraviolet light to generate reactive oxygen species that degrade organic pollutants. Fenton's reaction, adding hydrogen peroxide and iron salt to the effluent to reduce or to produce hydroxyl radical highly reactive species that oxidize organic compounds. Electrochemical oxidation, passing an electric current through the effluent to generate oxidizing agent that can break down the contaminants. Adsorption technique, activated carbon adsorbing organic compounds onto activated carbon surfaces, effectively removing them from the effluent. Ion exchange, exchanging ions in the effluent with ions on the resin surface to remove dissolved contaminants such as heavy metals or nutrients. So, these are technologies which we have studied, but here we are focusing on how to use these technologies for pollution load reduction. Combined treatment system, combining multiple treatment processes in sequence or parallel configuration to achieve comprehensive removal of contaminants and meet stringent discharge standards. So, by combining many methods, the final goal is how to reduce the pollution load and make it into a water system which is strictly following the stringent regulatory norms. Monitoring and control, implementing robust monitoring system to continuously assess effluent quality and adjust treatment processes as needed to ensure compliance with regulatory requirements. Employ automation and control strategies to optimize treatment efficiency and minimize energy and chemical consumption. By employing a combination of these treatment methods tailored to specific effluent characteristic and regulatory standards, industries can effectively reduce pollution load in their effluent and minimize their environmental impact. It is for sure that if all these methods which have been spoken out today in this lecture, if they are followed meticulously, carefully, then definitely the textile unit will have less of pollution load and will have better textile effluent which can be discharged into the water bodies. Recycling waste processes to reduce the pollution load in textile industry. This is also one of the aspects. Recycling waste processes in textile production can significantly reduce the pollution load in textile effluent by minimizing the generation of waste and reusing resources efficiently. Here are some key waste recycling processes: water recycling and reuse. And time and again we have been talking about it, because water is such an important and scarce commodity that now we have to worry about how to save water and how to keep fresh water intact. Implementing closed loop water system, where water used in textile processing is treated and recycled for further use within their system. This reduces the consumption of fresh water and minimizes the volume of wastewater discharged. Employing advanced treatment technologies such as membrane filtration, reverse osmosis and electrocoagulation to treat wastewater and remove contaminants, allowing the treated water to be reused in production processes. Dye recovery and reuse. Utilizing dye recovery system to capture and recycle dyes from process water and wastewater. If this can be achieved, nothing like it. Techniques such as membrane filtration, adsorption and precipitation can be employed to recover dyes for reuse in subsequent dyeing processes. Implementing dye house management practices to optimize dye usage and minimize losses, thereby reducing the amount of dye discharge into the effluent and obviously the pollution load reduction. Chemical recovery and regeneration. Not only dyes, but other auxiliaries and chemicals that are used in the processes must also be aimed to be recovered and regenerated. Recovery and regeneration of chemicals used in the textile processing such as alkalis, acids and surfactants through processes such as neutralization, precipitation and ion exchange. Employing efficient chemical dosing and management practices to minimize chemical usage and waste generation. So, all along chemical management, optimization, the less we use, the less will be the pollution load. Fiber recycling. Recycling of post-industrial and post-consumer textile waste to produce recycled fibers for use in new textile product. This is a new concept altogether. This reduces the demand for virgin fibers and mitigates the environmental impact of textile production. Implementing mechanical and chemical recycling processes to break down waste textiles into constituent fibers, which can be then respun into yarn and woven or knitted into fabrics. Energy recovery. Recovering energy from waste streams through technologies such as anaerobic digestion, which generates biogas from organic waste, or incineration, which converts waste into heat and power. Implementing energy efficient practices and renewable energy sources to reduce overall energy consumption and reliance on fossil fuels in textile production. So, both fiber recycling, which Reliance company is already doing, and you will be happy to know that all the jerseys that the cricket players wear are made up of recycled material. Similarly, energy recovery is also very important, and for that matter the anaerobic digester producing the biogas is a big source of energy, and that is like getting energy from waste. Effluent treatment sludge management. Recycling and beneficially reusable sludge generated from effluent treatment processes such as anaerobic digestion to produce biogas or composting to produce organic fertilizer. Implementing sludge, dewatering and drying technologies to reduce volume and facilitate reuse or safe disposal. Now, we know that biogas of course is very important component or byproduct of anaerobic digestion, apart from what it does for the degradation of the organic pollutants. But at the same time this can be also used for organic fertilizing, the composting of this sludge. So, sludge management also is very important, and we dedicated one full chapter or lecture on sludge disposal and management. Implementing sludge dewatering and drying technologies is also important. By integrating these recycling waste processes into textile production, manufacturers can minimize waste generation, conserve resources and reduce the pollution load in textile effluent, undoubtedly contributing to a more sustainable and environmentally responsible industry. However, there are lots of challenges. Reducing the pollution load in textile effluent is a complex task that involves various challenges. Some of the key challenges faced in this endeavor include complexity of pollution sources. The textile production involves multiple processes, each contributing to pollution load in effluent, dyeing, printing, desizing, sizing, curing, mercerizing, singeing, and then we have the finishing and washing operations release a variety of pollutants which include dyes, heavy metals, surfactants, emulsifiers, solvents and other auxiliary chemicals into the wastewater, making it challenging to address all sources of pollution effectively. We have seen, although many such adsorbents and other things have been identified for specific removal of heavy metals or for decolorization of dyes or for surfactants, but even then when they are together, to selectively remove one and more than one component becomes a challenge. Variability in effluent composition. Effluent composition can vary widely depending on factors such as the type of textile processed, production technique and the chemical usage. This variability makes it difficult to implement standardized treatment approaches and requires tailor-made solutions for different effluent streams. So, since the production is such that there are always different types of materials made or different types of fabric with different types of dyes used, and with the dyes comes the associated auxiliaries, the composition can never be the same, and when it is not the same, then a standard treatment strategy cannot be made. Every time it has to be tailor made in order to understand that now the effluent is having these characteristics. So, it should be modified accordingly. Lack of access of clean technologies. Many textile manufacturers, particularly in developing countries, lack access to clean and sustainable technologies for effluent treatment. The high cost implementing advanced treatment system and limited technical expertise pose significant barrier to adopting cleaner production practices, and many of these practices are now coming up. They have to be established. So, all the new research that happens in the area of developing new technologies have to be first implemented several times in order to be taken to the mill. All these research that are done are at the laboratory level. Even scaling up from laboratory level to mill level or large scale would require lot of adaptation. So, therefore, because of lack of clean technologies which have been developed at laboratory scale, but cannot be scaled up or have not been scaled up is another issue. Water scarcity and competition. Textile production is water intensive and in regions facing water scarcity, competition for water resource between industrial, agricultural and domestic users can exacerbate environmental degradation. Balancing the water needs of textile production with the preservation of freshwater ecosystem is a significant challenge. And I have been telling all along, right from the beginning, from the lecture number 1, that water is a very scarce commodity and we have to preserve it, whereas water is largely required by textile industry. So, we have to find a balance where water is used, but it should be recycled with closed loop system, so that less amount of fresh water is used again and again. Regulatory compliance and enforcement. While regulations exist to limit the discharge of pollutants from textile factories, enforcement mechanism may be inadequate or inconsistently applied, leading to non-compliance and continued pollution. Strengthening regulatory frameworks and ensuring effective enforcement are critical for driving industry-wide improvement. So, we have to abide by the regulatory compliances and they should be enforced properly. Behavioral and cultural factors, resistance to change and a lack of awareness for understanding of environmental issues among stakeholders within the textile industry can hinder efforts to reduce pollution. Overcoming entrenched practices and fostering a culture of environmental responsibility requires education, training and stakeholders engagement. Challenges are also there because supply chain is very complex. The textile production often involves complex global supply chain with multiple tiers of suppliers, subcontractors and intermediaries. Ensuring environmental standards and pollution control measures are upheld across the entire supply chain and can be quite challenging. Technological limitation. Despite advancement in clean production technologies, certain pollutants such as certain hazardous chemicals and persistent dyes remain challenging to remove from effluent using existing treatment methods. Continued research and innovation are needed to develop more effective solutions for pollutants removal and remediation. Addressing these challenges requires concerted efforts from all stakeholders including government, industry, association and manufacturers. Collaborative approaches that prioritize innovation, regulation, education and resource sharing are essential for achieving significant reduction in the pollution load of the textile effluent and promoting sustainable practices within the industry. So, with this we have come to an end. So, we will conclude by saying that in conclusion, reducing the pollution load in textile effluent is a multifaceted challenge that requires concerted efforts from all stakeholders involved in the textile industry. Despite facing various obstacles including complex pollution sources, regulatory compliance issues and technological limitations, progress is being made towards more sustainable textile production practices. So, it is still not very dark, there is hope, and the hope says that we can still combat all this problem of pollution load. Effective reduction in pollution in textile effluent requires a holistic approach that integrates innovative technologies, regulatory measures and industry-wide collaboration. Implementing sustainable dyeing methods optimizing water and chemical use, and investing in advanced treatment technologies are crucial steps towards minimizing the environmental impact of textile production. So, with this we have come to an end of this lecture. Thank you.